Alright, so we're looking at lesson 28 today. We're going to be talking about gravitational theory. So hopefully after this lesson you'll understand a little bit more about gravitational theory. I want you to read your book, page 170 to 172, about gravitational theory. It's a lot of information that I just want you to kind of be familiar with. If you have any questions, I can go over it. But once you get to Newton's law of gravitation, you can stop. We're going to go over from there. But just kind of read through about the gravitational theory. Alright, so Kepler's law, just a little bit of recap over what you just read. The orbit of every planet is actually an ellipse, and the sun is at one focus of the ellipse. If you've talked about an ellipse in your math classes before, your ellipses have two foci. Foci is the plural of focus. And then there's your ellipse. And it says that the sun is one of the foci. The line that joins the sun and a planet sweeps out equal areas in equal time. So sometimes it'll move faster, and sometimes it'll move slower. And you should have read that it moved faster as it was closer to the sun. The square of the planet's orbital period is proportional to the cube of the semi-major axis of its orbit. So those are his three laws that he came up with. So this is Newton's law of gravitation. F equals G m1 m2 over r squared. So G is your constant of proportionality. And he made a rough estimate of it. And it was greatly improved, but Newton did estimate it pretty accurately. In 1798, the estimate was improved by Henry Cavendish, whose unique experiment proved a value that was within 1% of the currently accepted value. So like I said, Newton was pretty close with his estimate. But this is the number that you need to write down. Probably put it on your formula sheet so you don't have to memorize it. 6.67 times 10 to the negative 11. M1 and M2 are going to be masses, and R is going to be a radius, or a distance. So we're going to use Newton's law of gravitation to calculate the force of gravity of the Earth on three different things. So we're going to use our formula that we just wrote down. F equals G m1 m2 over r2. Not r2, r squared. So for part A, our G is 6.67 times 10 to the negative 11. The two objects that we're looking at are a 1 kilogram mass and the Earth. And so you have to look in the back of the book to find the mass of the Earth. So turn to the back, go to like 7, let's see. Go all the way to the back and then flip forward 1, and it says planetary data. And so the mass of the Earth, it says is 0.0598 times 10 to the 26. I want it in scientific notation, so I'm going to move it 2 places. So 5.98 times 10 to the 24th. And then over the radius. So the radius is going to be the radius of the surface of the Earth on this one. So you're still looking at that, the back of the book, the table, and the radius of the Earth, it tells you is 6.37 times 10 to the 6th. So we're going to square that number. So now you've got to plug that into your calculator to get your answer. Okay, so we're only going to go to 2 sig figs because that's how many they give us. So you should get 9.8. And then our force is in newtons. So newtons would be your answer. Okay, now we're going to do B. So the only thing that's going to change on this one, the gravitational number is the same. It is the 100 kilogram mass instead of it being a 1 kilogram mass. We're still dealing on the surface of the Earth, so that's going to be the same, and the radius is going to be the same. Okay. And so you're going to plug that into your calculator. And so your answer is going to be 9.8, and we only have 2 sig figs here, so 980 newtons. So that would be your answer there. Now we're going to look at part C. Again, your G is 6.67 times 10 to the negative 11. We have a 1 kilogram mass, and we have the mass of the Earth. But now the radius is different. So it's the radius of the Earth plus the part that we are above the Earth's surface. Now I'm going to go back to the chart real quick in the back, and the radius was in meters, and they told us this was not in meters. 250 kilometers, 1 kilometer is 1,000 meters, so you have to multiply it by 1,000. So 250 and then 3 more zeros, so 250,000 is what you're going to add to whatever radius the Earth was. So now we're going to plug that into our calculator. And so if you plug that in and go to 2 sig figs, you're going to get 9.1 newtons for your answer. So that's how you use that formula. It's not terribly difficult. You just have to make sure that you're paying attention to all of the information they give you. Okay, so we're going to look at G m sub E over R squared. And at any given distance r from the center of the Earth, that formula is the magnitude of the Earth's gravitational field at that distance. So you can use that formula to find what the gravitational field would be at whatever distance you are away from the center of the Earth. The direction of your gravitational field is always going towards the center of the Earth, just like gravity is always going down towards Earth, towards the center of Earth. Your magnitude of your Earth's gravitational field at any point above the surface equals the numerical value of the acceleration towards the center of the Earth that a mass in free fall would experience. And they give you a table, 28.1 on page 173. And so if you are 0 kilometers away from the surface of the Earth, so if you're on the surface of the Earth, the acceleration due to gravity is 9.81. And then as you go 1,000, 2,000, all the way up to 50,000, your acceleration due to gravity lessens, because that means that the pull of the Earth is weakening from you because you're getting further and further away from it. So that's how that table can be used. If you have an object's gravitational potential energy, It is the measure of its ability to do work as it falls towards the center of the earth. So I want y'all to read page 174. It talks about negative potential energy. And then after y'all are finished, you can go over any questions that you have. But sometimes the book is just, it goes over everything, and you just need to read through it to kind of see what they're talking about. So those are, they only have that one example to go through. So make sure that y'all do 1 through 20 and the curveball questions for homework so we can go over any questions you have tomorrow.